but I wanted to go through it. So you remember some of this for when. Oh, I am recording. Crap! I just recorded all that. All right. So the first problem when we have an inequality, we solve it the same way we do a two-step equation. So it's just like if there was an equal sign here, except for one thing. Does anybody remember that one thing? You got to change something. Well, sometimes you have to change it, sometimes you don't. This time you do.
When it's a negative, you flip the sign.
Perfect. So if we have negative 6x plus 4 greater than 13, subtract 4 and subtract 4, same first step we would do. Negative 6x divided by negative 6 divided by negative 6. We get x equals negative.
What you mean equals? It's not what they mean.
Oh, yes, you're right. Thank you. I mean, I would have gotten to that next. As soon as I went into my spiel about why you had to flip it, I would have realized I didn't flip it. So we get x on the left, because we cancel out this by dividing by negative 6. Then we divide by negative 6 on the other side. Here is the one and only thing you have to remember that's different about solving an inequality versus an equation. If you divide through by a negative as the last step, you have to flip that thing. It's the only thing that's different. That's it. Now, if we were to graph this, when we graph an inequality, again, the trick about this is it's a one variable inequality. There's only one variable in this, just z, then a number. We write a circle on the negative 3, and then we shade the circle. Why did I shade the circle?
Because the
So what does that mean? There's a line there. What does that mean?
Equal to or something, whatever.
Close. It means that there's an equal to part of it, but what is that? What am I signifying by shading that in? Like, what does that mean when I shade it in? Pretty close. I mean, it's hard to explain, I know, but I'm just trying to see if anybody can. Here's what I mean. Shading this in means negative 3 is a solution. Negative 3 is one of our answers. And we know that because if I plug negative 3 in and I say negative 3 is less than or equal to negative 3, the answer to that is yeah, it's equal to negative 3. So yes, it could either be less than negative 3, all of our answers. Our answers could either be less than negative 3 or equal to negative 3. Well, negative 3 is equal to negative 3, so it's an answer. What else is an answer? Give me another answer. What's part of our solution set? Like one of our answers we could have. What?
Z.
No, Z. Well, Z does stand for it, but give me something Z could be. Give me a number Z could be. Yeah, it could be negative 5. Any number that is less than negative 3 or equal to negative 3 is a solution. That's what that means. When you see this expression right here, really it's an inequality, that means all of the numbers that are either less than negative 3 or equal to negative 3 are solutions. Every number that fits that. Well, negative 3 fits it, but then what other numbers fit it besides negative 5? Negative what? Negative 4 fits it. Yeah, negative 4 is less than negative 3. What other number?
Negative 5.
Does negative 2 fit it?
No.
No.
Negative 2 is not less than negative 3.
6, lower or equal.
Every number to the left fits. Any number in here fits too, like negative 3.1, negative 3.01. All of these numbers in here fit also. So we would have to shade in everything going that way. That's what the other shading was that we did when we graphed an inequality. So inequalities always deal with shading. The first question is, do you shade the actual number itself, which means fill in the circle? The next question is, which direction do you shade, left or right? Again, we did this before. It's one variable inequalities. We're about to get into two variable inequalities, which will be similar, but obviously they're going to have some differences. What's the difference in the last two? What do you think?
one of them, correct.
I do that like 6 times a day.
One of them said that he's currently going to the store to spend, and the other one says he's already spent the $10.
Well, I see that those are the words, but what does that mean? That's not the meaning, that's just the different words. Who can explain what those words mean? What do you think?
One is negative and one is positive.
No, we don't have anything to do with negative and positive.
It means one person is broke and the other has $10.
Wait, you talking about putting him
No, doesn't mean one person is
Wait, did
broke.
I get it right on my bell work? Because I can say it.
Who was up? So we did Christian, and then there was a guy that asked me somewhere over here. Okay. So you're up for bathroom. Shoot, I didn't, you need to leave. You went in the restroom, right? So you can go, you gotta leave your phone and basket, please. I forgot to do that with the first two, but I am doing phones for bathroom pass again. You don't have one?
No, this is background.
All right, so can anybody else explain what it means, maybe in a little more math sense? What do you think? Yeah, but again, you're just using the words. What does that mean? I see that. One says that spent, and one says to spend. I see that, and that's the word, but what do those words mean? What's important about that mathematically?
That's in Y.
Like, think about an equation. Well, how would those equations be different? Or how would the answers to those equations? Like, if the variable, or if our answers were how much money did she spend, how would the answers be different in those two problems? Well, what does that mean? That doesn't. I see that. You're just reading. You're just telling me what it says.
What does it mean?
Well, that's what
What
it
she
means.
got?
No, that's not what it means. It means more than that.
What, you skipped kindergarten? Come on, man. It's English.
No, I get the English part. I want to know how that relates to math.
Right there. I don't
Oh.
understand.
No, that doesn't relate to anything to
I
math.
get it.
Again, think about equations. What's in an equation? Or inequalities? Numbers.
And
Sometimes variable. So let's say we made a variable, and the variable is how much she spent. That's the variable.
How much? What did she
I
buy?
see what you mean.
How much items
This is a
It's not how many items she bought. On the right
What she
track
got?
though with that, I think. No, so it's more about cost.
Total.
What's
Negative 10.
so? Let's say
Oh, you're saying.
we're gonna do this equation, the second equation first.
Okay, let's-
X is the amount of money she spends, right? I'm making that equal to the amount of money she spends. Now finish the actual equation off.
I got you. It's on.
And is equal
X plus
or
Y minus
equal
the
or
There's no lie in this.
subtract.
No, we don't need that.
Equal or
It's
less
I'll give you a
than.
hint. It's already solved for us. We don't need the initial equation. We know the solution, but it's still, the solution is still in the form of an
X,
equation.
X equals 10.
Hey.
That's how much she spent. If the amount of money is X, the amount of money she spends is X. We know how much she spends. The amount, remember what I said about this, and I'm giving you a big hint if you haven't taken the test yet. What do we say that means in math?
That's what?
I think some addition.
Nope.
Equal.
Is means equals. The amount of money she spends is, so the amount of money she spends, because I just said that's what X stands for, is $10. So that's the equation for that. But what's the equation for the first statement? What's the equation for the first statement? X, it's still X, because that's the amount of money she spends.
Y.
equals
X.
0.
No need for a
No,
Y,
X
because there's
equals
no,
0.
nothing else, there's no other missing, it's just, the only thing we don't know is the amount of money she
X
spends.
equals negative 10.
X equals question.
Not a negative, has nothing to do with spending negative
It's
money,
just X.
Equals.
still just X.
X equals.
Does it equal 10? Does she
No.
definitely spend $10?
No.
No,
Negative
definitely
10?
spend, she's going in with
Negative
$10, doesn't
10?
have to spend.
No,
That's what he
it's
said.
X equals, no.
That's what Joe said.
What's an amount of money she could spend?
No.
She could spend 10, what
It's
else?
just X.
2.
Could spend 2.
She can spend any.
$6, $7, $8,
Y.
No.
$3, $2.
That's Y, that's two.
X equals infinite. X equals
So
infinite.
what is the symbol we need? Does anybody?
Infinity.
No. What is an amount she can't spend?
Spend more.
11.
Say that again. She can't spend 11, right?
Did y'all hear me? She said she could.
It said X.
Did you say a symbol earlier?
No.
Oh. She can't spend 11, right? She can't spend 12. Can't spend 15. Can't spend 20.
Not 13.
So what has to be the case? What's kind of the rule, sort of? She can spend what? What's the rule?
$10.
The amount. Oh, what'd you say in words?
You know what? Shut up, because I just said that.
So
Oh,
we
wait,
just
no,
said.
I said she could spend anything less than 10 after I named all those numbers, bro.
So we just said in words that the amount of money she spends, which is X, like in words, the amount of money she spends, and then we said in words what? Is less than, or what?
Or equal to 10.
Or equal to, she could spend 10 again.
No, but equal to less than 10.
That's the difference right there. That's the difference in those statements. And one of them, X equals 10, and one of them, X has to be less than or equal to 10. So one's an inequality, one's an equation. That is Aaron. So who was the top after Aaron? Somebody asked me.
I asked, can I listen to
No. You're on parole or on probation.
You let me go last time, and I was answering questions too. Can I go, Mr.?
You got 5 minutes. Phone's in there. You got 5 minutes, or else you're back on. You do interact, and that's the only thing that gets you out of trouble, because you get into a lot of trouble. So this is the difference. You need to understand when something's an equation versus an inequality, and the hints are going to be mainly that the answer can have a lot of different answers. Like it could be less than or equal to a number. Here are some words that are important in word problems. So jot these down. You'll see some of them. Obviously, if it says less than, greater than, something like that, or equal to, like these are, I mean, that translates directly into the word problems. So all of those things are the keys, and it's an inequality right there. So, like, I'll just say like inequality hints or something like that. And then in word problems. So in word problems, if you see any of those things, so if you look at the last problem on your sheet, so everybody look at number 5. Again, this is your quiz for Friday for you. So look at number 5. Do you see any of those words in there? Or any of those phrases, words, something. Anai, what do you think? Do you see any of those phrases in the word problem? At most, at least, less than, greater than, equal to, or equal to? Which one? I'm talking about number 5 on the sheet that you picked up. Look in that, read, everybody read that, because you're going to wind up underlining this in a second. I mean, you can underline it now if you've already found it. I'm asking you, do you see any of those phrases? At most, at least, less than, greater than, or equal to?
I do.
Better. I've already asked somebody, she'll read it. She'll find it. Which one? Is it at most?
No, at least.
At least, right? Yeah, at least. So again, underline at least in that word problem. I'm going to tell you what at least means. I mean, you can also kind of think about what happens. If you're raising money for something, all of you have probably raised money at some point, I'm guessing. Or if you just want to, you're just trying to earn money on your own, either working at a job or an allowance or whatever. you want to make at least enough money to buy whatever you want.
Yes.
But are you fine, like, let's say it costs $50. Are you fine if you make 55?
Yeah.
Sure. Are you fine if you make 60?
Yeah.
Are you fine if you make 100?
Yeah.
Sure. Are you fine if you make 40?
No.
No.
No. So you need that number. So the amount you raise, again, the variable would be the amount of money you make,
Yeah.
or the amount of money you need, has to be what? So 50 is the amount you want. So if this is the amount of money you make, what's the symbol we need? When it's at least, because you want at least $50. Well, X is the variable, but what's the symbol? The amount of money needs to be what? Or you can say it in words if you know the words.
At least.
Well, at least it's already in there. I'm saying what's the words for the symbol. Could be equal. It could be. So the amount, I'll write it in words down here. I'll change those. Then it'll stand out. So the amount of money you raise or make, amount of money needs to be something. We're going to fill in that blank. $50. So there's my word. That was super fast. Good job. So the amount of money that we make needs to be what compared to $50?
10. Wait, 80. Wait, hang on.
Could be equal, but it doesn't have to be equal. We'd be fine also if it was what? There's the word I was looking for.
Equal.
It needs to be greater than or equal to.
So it's
I didn't put greater than, but you get the point.
it's this type of sign.
So what sign do we need then? If you can say it in words, you can figure out the sign you need for the equation or the inequality.
It's an arrow with a
Which
line
way is
in
the
it.
mouth going to be open?
It goes that way.
It's gonna be open.
Is X going to be bigger than 50 or is X going to be smaller than 50?
Bigger.
Mouth is open.
Equal.
Bigger.
Exactly, because we need X to be bigger than 50, right? Alligator eats the bigger number. If you don't remember that, if you don't know what I'm talking about.
Yeah, the mountain.
When you learned like greater than or equal to and less than or equal to and all that in like elementary school, you learned about an alligator. They probably did a big story behind it. This is an alligator mouth. I'm a fantastic artist.
Alligator.
You don't have to draw alligator line.
I'll let you, do you want to come draw one? I'll let you come draw one.
We draw alligator. Oh, God.
Yes. Yes. Oh, yoga.
It's an
Oh, that's a head.
I don't have a,
Hey, yo.
well, I gotta draw a really big mouth.
Wait, what? I thought the mouth was the other.
Uh,
That's a really fat alligator.
Fantastic. Oh wait. There. Fantastic.
Yeah.
It looks like a dolphin.
No, this is how you
Except for
draw
a dolphin with legs.
an alligator.
Looks like a mutated creature.
And you just draw on it. You have
That's
to draw
just a
it.
mouth. I wanted the whole
No.
alligator.
You forgot the-
bad.
Anybody could do that. Anybody could do that. So the point
Just
is,
draw Pac-Man.
the alligator eats the bigger number. So if we need X to be bigger than 50, which we do, because we need to have at least $50 or more in order to buy whatever we want, then we need the mouth to be open because that's the bigger number that way. And then we also need the equal sign. Because we could earn exactly 50 and we'd be okay with that. We could still buy it. That's your so that's, if you can say it in words, if you can figure out how to say it using greater than, less than, equal to, all that, that'll tell you what symbol you need. The amount of money she makes or she earns needs to be greater than or equal to 50, greater than or equal to 50. All right, so we're gonna kind of do an intro to it today, and you do have some work you'll do independently. So I'm gonna play the video. I'll stop it we're not even gonna get to the second video. I'll stop it every once in a while to kind of, he goes really fast. So I'll stop it to try and fill in the gaps when he's doing different pieces of it. And then we'll do a worksheet on graphing at the end for the last 15 or 20 minutes, which will continue next class. And we'll get to the word problem next class also. Oh, and so again, this video, there are going to be some things I point out. So if you'll notice, I've started to put like 1 or 2 questions on every quiz. That's like a explain this to me kind of question. And a lot of us don't do so. And they're right in your notes. Like some people get it perfect because they say or write down exactly what I tell them to write down. And then they just repeat that back on the quiz. Some of you don't have it in your notes. So I suggest when you watch this, when I stop it, you write down the stuff that I'm saying when I stop it. So the whole point of me stopping it is to go over something I consider important, because you're probably going to wind up seeing it again. Clearly it won't be on this exit ticket, because I've given you this exit ticket.
What's up, everyone, and welcome to this in-depth lesson on graphing linear inequalities. Now, at this point, we already have a whole collection of algebra skills that we're going to apply to this new concept.
We're going to
Let's
skip
start
over
off
this
with
because we already
solving
did
a
this.
simple equation. In this case, x plus 5.
We already did all of that stuff. Is the bell
Imagine
work?
that, but not including. Inequality is going to look like.
All right, here we
on the
go. So
coordinate.
now we have 2 variables. Here's the difference. Well,
Can you
Christian
give us
first.
that?
We already know that in linear
What did you-
equations, such as y equals x or y equals negative x,
Can you get rid of that?
at any point
Yeah.
on the line is going to be.
I'm going to go over all of this in a second.
But we're interested in inequalities here. So if these were inequalities instead of equations, it would look a lot different. If we had y is greater than or equal to x, we would have to shade all the area above the line.
So again, when we're
And
dealing
if
with
we had y
inequalities,
less than or
we're
equal to
dealing with
negative
shading.
x, we
Notice
have to
how he's
shade
shading it in a different way though now, because we have 2
Now this
variables.
shading is dependent on the inequality sign. When we have a greater than or equal sign, we are going to shade above the line.
All right, so let me explain what he did really super fast already. He's assuming you know how to do all this stuff, so we're going to go over it. So when we have an equation, and I do mean an equation right now. So, and by the way, this is not anything new. You're probably like, holy crap, we've never done anything like that before. That looks ridiculously difficult. We have done it. We've absolutely done it. We just are used to seeing it in a different format. We're used to seeing it like this. Mx plus b. The m just happens to be 1, so we don't write it in front of the x. And the y-intercept is 0. That's why it's going, well, can't see it because it goes through the arrow, but the line goes through y at 0. Well, we don't need to write plus 0, so we don't write the plus 0 on the end. But basically, this equation is the same thing as that equation. So it's not anything new. It's the same exact thing we've been working on. Y equals mx plus b. Y equals mx plus b. So what he said, if we think about this as an equation, so let's say we don't have the inequality symbol. Let's say we have, no, I just wrote that. Why is that not? There we go. That was weird that it wasn't erasing. Huh. Don't know what was going on with that. So let's say it wasn't an inequality yet. Let's say we started with that. That's when we used to graph lines, and we said the line is every possible answer, right? Because we don't know what x and y are. X might be 2 and y might be 2. Or x might be 3 and y might be 3. Or x might be -1 and y is -1. If you'll notice, all of these numbers on that line are where x and y are the same number. 4 and 4, 5 and 5, 6 and 6, -5, -5, -9, -9. Every y and x are equal to each other if we were just to do the line itself. And again, this was one of the questions on one of your quizzes, and it'll probably come back. Nobody understood what a line was. A line is the answer to the equation. Well, some people got it. A line, and again, nobody's writing it down right now either. A line is the answer to the equation. Like it's all the possible answers, all the ordered pairs, all of the x's and y's. Like I said, if I pick x right here, or -6 and -6, well, at -6 and -6, x would equal y. So it is the answer. It's just we don't know which answer yet, because we have two variables. We can't solve it if we have two variables. So all we can do is graph all of the possible solutions. So now if we change this to this symbol, so we still have the equal to part, so the line is still possible solutions, because everywhere on the line it would still, x and y would be equal. But now we don't have to just be equal. We could actually have the y be greater than the x. So if you'll look at every single point in here, and this is the shaded region, every point in that shaded region, whatever y is, it's greater than x. So let's just pick a point. What is the coordinate or the ordered pair for that right there? What am I going to call shaded? You're close, although I think your vision is still pretty bad. Renata, you're close. Although is your vision bad? You can't see that point either?
Y equals 7, x equals 3.
All right, somebody that can see, thank you. So this point right here, x is 3, y is 7. So if we were to write that as an ordered pair, 3, I'm trying to write it really large. That is the ordered pair, 3, comma, 7. So x is 3, y is 7. Well, if we plug that in, x is 3, there's my symbol, y is 7. I'm going to get rid of this now. Hopefully you understand that that's the same equation. So I just took these two these two x and y values and plug them in for x and then y. Is 7 greater than or equal to 3? Could be either. Could be greater than 3 or equal to 3. Is it?
Where'd you get 3 and 7?
Hold on just a second.
It's on the shaded side. Wait, no.
Yeah, but how?
It is. I just picked a point in the shaded side. I'm just picking any point in the shaded side. So I just said, let's pick a point. Because so the shaded region is all the possible answers. So again, you need to write that down. The shaded region is all the possible answers to the inequality.
Wait,
Write that down. Shaded region. Shaded is the blue and green. That's his shading. That's the way he's shading it, in the blue and green. I'm going to say it again. The shaded region, and this is again for inequalities, because you don't need to shade in a equality if it's an equation. The shaded region, and I'm going to say a different word than what you probably wrote, but it represents all the possible solutions to an inequality. So I'm just proving that to you. I'm going to just pick a few different points that are in the shaded region, and you'll see that, yeah, every point in the shaded region is an answer. It makes the left side, in this case, the left side will be greater than the right side. The points on the line are the ones that are equal. So we've already tested those. So I'm not going to test any of those again. But every point on the line would make y equal to x. I'm just testing y greater than x right now. So again, if this is the point, I just picked this point, randomly picked it. So your question, Jose, was how'd you get the 7 and 3? I just said, well, I'm going to test this point out right here. I just chose it. So I'm just going to now say if this point is at 3 is my x and 7 is my y, that better make this equation, it better make y greater than x. Well, I plugged in the numbers. 7 is greater than 3. So yes, it does work. So it is a solution, which we already knew because he already shaded it. Now let's plug in one way down here though. Maybe we said, well, maybe it doesn't work for negative numbers. What is that point? Who am I going to call on? Nicole. What's that point? What's my x and y for this down here? It's actually at -7. I know you probably have a bad angle, but so the and the x is -7. So here, this point right here is -7, comma, -5. That's my coordinate, my ordered pair for that red point that I just randomly chose. Well, now let's plug them back in and make sure it makes that equation true. So my y value is what? Joe, what's my y value for this new point I'm testing down here? -5 is my y. And that's got to be greater than or equal to my x, which is what? -7. Is that true? Is -5 greater than or equal to -7? Think of your number line again if you don't remember how to do.
Yeah.
Is that true? Malik, is -5 greater than or equal to -7? How do you test it? I'm going to go over that again. If you don't remember this, you need to write this down. You don't write stuff down. Think of a number line. The numbers get smaller as they go to left. They get bigger as they go to the right. So if something is the number that, so if you're comparing two numbers, the number to the right is the bigger number. So I'm comparing that and that. That's my two numbers. The number to the right is the bigger number. Always, because as I go this way, I'm getting bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are getting bigger. It's easy to see with positive, but it's the same thing over here. As I go to the right, numbers are getting bigger. So 5 is bigger than -7. So yes, -5 is greater than -7. So that is true. So that shaded region represents any point in that shaded region. I don't care which point you choose, the y value will be greater than the x value. The points on the line, they'll be equal. But in the shaded region, y will be greater than x. We could even test one that's not in there if we wanted to. Let's test like this point right here. What's that point? So this should not work because it's not shaded. So what's that point? Ever, what's that point? That one right there. This red one, yeah, there are a few red ones, but that red one right here. 3 comma what? What's the y value? It's hard to see, but it's 1. So that point is 3 comma 1. My x is 3, my y is 1. So let's test that out in the equation. So my x is 3. My y is 1. Is 1 greater than 3? Greater than or equal to 3? Fernando, is 1 greater than or equal to 3? Is 1 greater than or equal to 3? Well, it's a yes or no question. The question is so 1 is greater than 3? No. You guys have got to understand, it's not an either or. Is the number 1 greater than or equal to the number 3? Is the way that you're thinking about that question. So no, the number 1 is not greater than 3 and it's not equal to 3. So the answer to that is no. That is false, which it should be because it's not in the shaded region. So here's the very least. Here's what you need to know conceptually. 3 things. 1, the shaded region is all your possible answers. So that's the number 1 thing. Shaded region, all your possible answers to the inequality. So write that down. Shaded region is all the possible answers to the inequality. A lot of you not writing.
You said it a while ago, sorry.
But if you already wrote it, that's fine. So again, last time, the shaded region represents all the possible answers to the inequality. Well, I shouldn't say all the possible answers, but every point in there is definitely an answer. So now, next, the second thing, the non-shaded region is what? Not answers. The non-shaded region, not answers to the inequality. And you'll never have some points on one side and some points on the other side. It's either all or nothing. Just like when we did the number line, we only shaded left or we only shaded right. We never had some points on the right and some points on the left that made it true. So, and then the last thing, so again, that one was the non-shaded region, or not answers to the inequality. The last thing is the line. It's kind of like the borderline. And depending on the symbol, if it's an equal to symbol, they're also answers. If it's not an equal to, they are not answers. And then would be a dashed line. He's going to go over that in a second. But it's the equivalent of like when we do an open circle versus a shaded circle, like that's what we did when we graphed before. We said an open circle was when there was no line underneath. A closed circle was when there was a line underneath. It's kind of similar, only it's going to be a dashed line versus a solid line based on there being an equal sign underneath. He'll show you that in a second. All right, so I'm going to go ahead and let him finish out, and then we'll spend like 15 minutes on the worksheet. I'll do one of them as an example for you. And I don't mean this worksheet. I'm going to pass out another one.
And when we have a less than or equal sign, you're going to shade below the line. So maybe now your mind is blown and you're asking, what does this mean? We already established that when it's an equation, all of the points on the line are solutions. Now with inequalities, not only those points on the line are solutions, but the points in the shaded area are all solutions as well. And later on in this lesson, we'll explore why. Now, this is the case when we have the greater than or equal to or less than or equal to symbol. If we were to replace those inequality symbols with just greater than or less than, like we're going to do right now, this changes things a little bit, because now the points on the line are no longer included in the solution, and only the points in the shaded area are. In these cases, we'll be using a dashed line to indicate that the points on the line are not included in the solution. So if you're seeing this for the first time, it might be a little confusing. So before we get into any examples, let's just try to clarify here. If we have the inequality x is greater than or equal to 2, we could say that the solution is any value greater than or equal to 2. So any number larger than 2 and including 2. However,
So again,
if it was just a greater than symbol, x is greater than 2, our solution would be any value greater than 2, but would not include 2. So when graphing these linear inequalities, the greater than or equal to or less than or equal to symbols have a solid line where the points on the line are included in the solution.
All right, so here's the part you need to remember right there. When you create the line, so like you have y equals mx plus b, sometimes you'll also do this from the cover up and solve method. So like you won't have y all by itself, you'll have something times x, and then plus or subtract something times y equals a number, and you'll do cover up and solve. But the key is, if you have one of these two symbols, when you get to the part where you actually draw the line, like you have your 2 points that you need, now you're drawing the line. If you have these two symbols, you'll make it a solid line. If you have or one of these two up top. If you have one of these two, you'll make it a dashed line. Because the solid line means yes, all of the points on the line are part of the solution. The dashed line means no, the points on the line are not part of the solution. That's why we make it dashed. This is the equivalent of like an open circle versus a closed circle when we did the graphing with just one variable. I'll give you a second to copy those symbols down, and then and you may want to write, draw a solid line above that. And then here, if you have these, draw a dashed line. So that's probably what you would write. If you have these, draw a solid line. If you have these, draw a dashed line. So we'll wrap the video up in the next probably 2 or 3 minutes, and then we'll move on to the worksheet. And we'll do a few problems on, well, I'll do one with you or for you, and then you guys will work on it for the rest of the class. All right, so everybody should be done with that.
Where the points on the line are not included in the solution.
There, and he just finished it up.
So now we are ready to check out our first example, and we'll consider linear
This
inequality.
is really similar to number 2 on your future.
Graph is just like a linear equation by starting
number
at
2 real
y-intercept
quick with the
negative
equation.
2.
And actually number 1 he just did for you also a minute ago.
And since our symbol
Sort
is
of.
greater than
He
or
drew the
equal
line
to,
for you at least.
our line is going to be solid.
So again,
That's
solid
greater than
line
or
because he has the equal to
also
part under
means
there.
that we have to shade above the line, so the entire region above the line.
So he doesn't explain this very much, why
So now
you, which side you shade. So there's two ways to do the shading. I'm only going to tell you one right now, because frankly, the second one you have to understand a little bit more. Well, this one you got to understand too, I guess. So here's what you need to do. So let's say you've drawn the line, and you know if it's dashed or solid. That's the two steps. First, you draw the line. How do we draw the line? How do we draw this line? What's our process? Y is all alone. What's our process when Y is all alone?
You go with it.
This is what you're about to do, by the way, on those worksheets I just handed you. No, this is not a cover up install. When Y is all alone, we don't cover up install. When Y is all alone, we have slope and Y intercept. So what do we do? No, not yet. Not yet. Slope's not the starting point. What's the starting point? Huh? How do we draw the line though? Like he drew it for you, but he skipped over how to do it. And we don't know how to draw lines, obviously. No, I'm saying how do we get the line? Like before he got the line, right where it is. What are all those big green dots? Why are they there?
You need equation.
What did you say?
The line reading.
I think that was. I don't think that was.
So
What'd you say? They are the answer, but again, the way they got there, he didn't know that was the answer until he graphed this equation. How do we graph that equation?
You told us a line not the answer to an equation.
It is, but we got to graph the line before we know what the answers are. First, you got to graph the line. Once you graph it, yeah, the line is the answer. But we got to graph it first. How do we graph it? This explains why we didn't do very well on this question on the quiz. We graphed. This is just graphing. This is an equation, and I want you to graph that on, which he already did. So let's say we were here. Let me back up. Maybe this will help clarify it. We got to get, well, I need a little more than that. There. We got to get that. That represents a line, right? Y equals mx plus b. We need a line over here. How do we get it? He did it for you real fast, but you need to know how to do it. That's what you're doing on this worksheet.
Pencil, you put it later.
How? Where do you start?
With your paper.
Where?
The paper.
And how?
With
Graphing.
Alright, so
Now you
this
see it.
is how.
I'm dead serious right now.
Yeah.
Because again, most of you are going to find you're going to be struggling to pull this quarter out.
Right. So you just ignore
So you can joke around all you want, or you can try to learn this.
You ignore this, and then you put 3x. So
Nope. You actually did the opposite.
Yeah, you put the y here, and then you go up.
Nope.
3x.
No.
That's still an equal sign.
You treat it like it's an equal sign when you draw the line. It's just like it said y equals 3x subtract 2. Same way we learned how to graph that, even though, like I said, we're still struggling with it. Well, I'm spending more time on it than I probably should, way more than he did. Where did I start on that? Yeah, we started, which is what? Do you remember what it's called?
Negative.
It's called the y something.
Intercept?
Yeah, there we go. Finally, that only took 2 minutes. That is the y-intercept. That's your starting point. Again, this is only when y is all by itself.
What about our slope?
So that'll be the next step. So first we put the dot here though. So that's our starting point. Right there. And I just took that straight from the equation. Like, this is why this is not hard. Like, you guys are sitting here struggling with something that is way easier than a lot of stuff you're going to be doing next year. When you do the full algebra class, the second part of algebra is way harder than this. So if you don't have these basics down, you're going to really struggle next year to do well in that class. And it's like half the time. You got to realize we're taking this class over a full year. You're taking half of algebra over a full year. Next year, you take all of algebra in 1 year. So it's going to be going twice as fast.
I see what you did here.
So I just say this is the y-intercept. So I put a point right there. That's my first point. Now what do I do? Now I'll say the part you said a second ago.
Slope?
I take this number, which is the slope. I know the slope formula.
Rise up,
is rise over run. Well, I'm going to actually write the 3 first. I know the formula is rise over run, but what's the problem?
Yeah, put the number right there.
Yeah, I don't have a run number, right? I need 2 numbers there. If I had a fraction there, I'd be good, but I don't. So I need to make it into a fraction by putting it over 1. Again, if you already have a fraction, you don't have to do that. Now I count. I don't just, like again, I still got a quarter of the people in classes saying, oh, I go straight from -2 over to +3. That's how I do it. Piece of cake. No, it is not like that. Not like that. And I had a ton of people do that on the quiz. And I even specifically said, do not do this. As soon as I saw they did this, I knew they didn't pay attention enough. We don't just go from here up to this number. We need to create a fraction, and we need to say, well, a positive run means I go right 1. A positive rise means I go up 3. So from here, I go right 1 and then up 3. And that gives me the second point that I need. Now I could keep going right 1 and up 3 and right 1 and up 3, and that gives me more points to draw a straighter line, and it makes sure that I'm hitting all the spots I should be hitting. I could even say this. I could say that's the same thing as -3 over -1, because you can flip the sign and that still equals +3. Negative divided by negative is still +3, which is what our slope is. If that confuses you, just ignore it. But that's how I would be able to say, here are the other points. Over 1, down 3, over 1, down 3. So now I have a whole bunch of points that it allows me to draw a pretty straight line if I don't have a ruler or something like that. Because it is important sometimes to make sure you go through exactly the right spots when you graph. So that's how you graph that type of problem, which the whole first page is graphing just like that. That's why I spend so much time on it. So if you look at the worksheet I handed out, all of the problems on the first page are all y by itself, and you're going to use that method right there, which we'll get to, and I'll let him finish out. And then the way you find the shaded region is you're going to check a point. I don't think he does that either, so I guess I'll have to do that.
After this, just like a linear equation, by
So you
starting
just
at
put a
the
point
line,
there,
you set
and
-2,
then if you'll notice his
using the
point
slope to
fell
build
right
the
on our
line.
points.
And since our symbol is greater than or equal to, our line is going to be solid.
So solid line because of
That
the
greater
equal
than
to
or
part.
equal to symbol also means that we have to shade above
Now here's the
line.
part he
So
doesn't spend any
entire
time
region
on.
Above the line is going to get shaded.
So here's the last part of graphing that you'll do on that first page. Well, both pages, but mainly the first page today. Once you have the line, you still got to know which side to shade. You're always going to shade one side if there's an inequality sign. You really would want to pick a point. Pick 0, 0 to test. That's like your test point. And you plug those numbers into the equation, and then if it makes in this case, the left side needs to be greater than or equal to the right side. If the 0, 0 point makes the left side greater than or equal to the right side, then that's your solution side. If it doesn't, then the other side is your solution side. It's always going to be either one or the other. It's never going to be some points on one side, some points on the other side. So either I'm going to shade left, or you can think of it as up, or I'm going to shade right, or you can think of it as down. So let's plug in 0. So I'm testing this point. Again, I just randomly am choosing any point. If I choose 0, 0, because it makes my math really easy. Because if I plug in 0 here, greater than or equal to 3 times 0, so 0 for x and 0 for y, and then I say subtract 2, well, that all just goes away, and I get 0 is greater than or equal to -2. Is that true? Anaya, look up. Is 0 greater than or equal to -2? Think about your number line. Yeah, it's to the right. Right? If you're comparing two numbers, the number to the right is the bigger number. Well, here's 0 on the number line. Here's -2. 0 is to the right of -2. So yes, that is true. 0 is greater than -2. which means this side is my solution side. Because that's where 0, 0 is. It's on the left side, and that's the point I tested. All right, so now look at number 1 on your sheet. I'm going to do that one for you real quick. What is it? Y equals negative 2x subtract 2? That's it, right? All right, so again, same exact thing we just did. Let me see if I can zoom in a tiny bit. Oh yeah, definitely zoom in. Go. All right, so here we go. Y equals, you can see it on your sheet. I'm going to go ahead and scroll down to see more of the graph. So what is my y-intercept? What's my starting point? Well, negative 2, right? It's the end part of that equation. So negative 2 is my starting point. What's my slope? Look at the equation. It's on your
The
sheet.
slope is 2.
No, look at your equation.
Negative 2.
Negative 2 is also my slope. So in this case, it's the same number. I actually hate it when they do that. But so my slope, negative 2, which is going to give me my rise and my run that I'm going to use to count left and right, up and down. What am I missing?
R1.
I don't have a run number, right? Now I have everything I need. So a run of positive 1 means I go right 1. A rise of negative 2 means I go down 2 because it's negative. We wrote that stuff down a while. I'm not going to write it right now. We need to get on that sheet. I'll write it maybe while you're working. So I go right 1 and then down 2. There's my second point that I need. Now I could keep doing that and go right 1 and then down again, or I could reverse it and instead of going right 1 and down 2, I could go left 1 and up 2, and that'll give me some additional points that I can use to draw a straighter line. So that's my line. Here's the next question though. Should that be a dashed line or a solid line? Look at your equation. I don't have the equation anymore on the screen. What's the symbol in your problem?
A solid.
What's the symbol?
It's
I believe it's got the equal to under it, right?
Yes.
Then yes, it is a solid line, so I'm good with that. So the last thing I need to do is I need to determine which side to shade. And this is the most complex thing. So I write my equation. You need to write this step down right now. And you need to write above it to determine which side to shade or something like that. Like, or this is how you determine which side to shade. You write the equation. You then plug in 0 for x and 0 for y. Now, if the line goes through 0, 0, you can't do this. Because then 0, 0 is on the line. It can't be on the line to do it this way. You'd have to choose like 1, 1 then. Like you'd have to plug in 1 for x and for y. But I plug in 0 for y, 0 for x, and I get, oh, and I forgot my symbol. Symbol is what? Greater than or equal to or less than or equal to? Greater than or equal to? So is 0 greater than or equal to negative 2? Yes, it is, right? So 0 is a solution, which means I need to shade the side where 0 is. So I just tested that point right there. That point is a solution, then everything on that side is a solution. If one point works, then every point on that side of the line will work. So I would then come up and I would shade in. And I would shade in this side of the line. Oh, there we go. It's not working. I don't know why it's not shading. I think it'll catch up in a second. But so you can go ahead. There it goes. You can go ahead and get started. I just did number 1 for you. Every line on the first page, you use the slope intercept. So what is the y-intercept? What is the slope? And then when you go to shade, as long as the line doesn't go through 0, 0, you can use 0, 0. If the line goes through 0, 0, then you have to choose like 1, 1, and 1 for your x.